We're going to look at finding zeros of a variety of different polynomials. You will probably want your flip book in order to have some of those shortcuts handy. First of all, we need to go back through and look at terminology. We've worked with the term finding zeros before, and what that basically means is we need to set our equation equal to 0, factor it using any method, and make sure we get it factored as far as possible, and then we use the zero product property. So here's our first example. We have 2x to the fifth minus 14x cubed plus 28x is equal to 4x. First thing I have to do is get the equation set equal to 0. So I'm going to subtract 4x from both sides. And I would have 2x to the fifth minus 14x cubed plus 24x is equal to 0. Now, as I begin to start factoring this, I want to see if I can pull any common terms out. And as I look at the numbers, 2, 14, and 24 are all even numbers, so I can pull a 2 out. Then I also notice that all of these values have an x, so I'm going to pull an x out also. That 2x is going to get set down in front, and when I divide everything else by 2x, I'm going to be left with x to the fourth minus 7x squared plus 12, and that's going to be equal to 0. Now I've got it partially factored. This 2x here is partially factored. Now I have to see if I can get this x to the fourth minus 7x squared plus 12x factored down any farther. And what I'm going to do is, since it's 3 terms and it doesn't appear to follow a perfect square trinomial because the 12 is not a perfect square, I'm going to go ahead and just try to regular factor this. Now x to the fourth, I could have an x and an x cubed for my first 2 terms, or I could have x squared and x squared. I'm going to go with the x squared and the x squared because if I look at the rest of my equation, that's the only other kind of x that appears, is I have a minus 7x squared. So I'm going to do x squared and x squared. Now this plus sign by the 12 tells me that my signs match. The minus sign by the 7 tells me that they match as minuses. If I go back and I look at my factors of 12, I could have 1 and 12, 2 and 6, 3 and 4. Now I don't have any numbers in front of my x squared except for 1s, so I can just look at the old rule, which ones will get me to a 7? Well, the 3 and the 4. Now as I FOIL this back out, my first is going to give me x to the fourth, outside would be minus 4x squared, inside would be minus 3x squared, and last would be plus 12. That would be x to the fourth minus 7x squared plus 12, which is what I have in this set of parentheses right up here. So I've got it factored. And now, as I look at this, it's still all set equal to 0. I can stop factoring here. Even though this x squared minus 4 does follow a difference of 2 squares, I can stop factoring because each of my quantities only has x in one spot. That means I'm safe to do algebra now. So I'm going to go ahead and set 2x equal to 0. I'm going to set the x squared minus 3 equal to 0. And I'm going to set the x squared minus 4 equal to 0. This is my product, my zero product property. One of these values has to be equal to 0. So on my 2x equals 0, divide both sides by 2, and I get x is equal to 0. On my next one, x squared minus 3, add 3 to both sides, square root both sides, and I get x is equal to plus or minus the square root of 3. And the last one, add 4, square root both sides, and I get x is equal to plus or minus the square root of 4, which is plus or minus 2. So all of these are my zeros. X could be 0, or it could be plus or minus the square root of 3, or it could be a positive 2 or a negative 2. Okay, here's 2 more practice problems. Now in this first one, I notice I have 2 terms, I have a minus sign, so I'm probably going to be using the difference of 2 squares or the difference of 2 cubes. First thing, I'm going to pull out a 2x squared from each quantity. Now when I divide both of these by 2x squared and 2x squared, I'm going to be left with 16x to the fourth minus 1 is equal to 0. Now the 16x to the 4th, I'm going to break that down, and I've got a minus sign, I've got two terms. I'm going to break it down using the difference of two squares. So I'm going to rewrite 16x to the 4th as 4, because 4 squared would give me the 16, and then the x squared would give me x to the 4th. My 1 would break down into 1 squared. So when I factor this, I'm going to have 4x squared minus 1 and 4x squared plus 1. I still have this 2x squared out in front now. Now I notice that this 4x squared minus 1 follows the difference of two squares pattern again, because I could rewrite it as 2x squared and 1 squared. So I'm going to factor this middle one. Now the 2x squared out in front just stays. This 4x squared minus 1 is going to turn into 2x plus 1 and 2x minus 1. The 4x squared plus 1, that doesn't follow any of the special patterns because it's a plus sign and it's a square. So it's just going to have to stay 4x squared plus 1. Now I've gotten it factored. It's still all set equal to 0, so I have to take each quantity and set it equal to 0. So I'm going to set my 2x squared equal to 0. I'm going to set 2x plus 1 equal to 0. I'm going to set 2x minus 1 equal to 0. And I'm going to set 4x squared plus 1 equal to 0. Go back and divide these both by 2. And I'm going to get x squared equals 0. Square root both sides, and I get x is equal to 0. This second one, subtract 1 from both sides, and I'm going to have 2x is equal to negative 1. Divide by 2, and I get x is equal to negative 1/2. Third one, add 1 to both sides, and I'm going to have 2x equals 1. Divide by 2, and I get x is equal to positive 1/2. And my last one, subtract 1 from both sides, divide by 4, and then square root both sides. Now notice, when I square root this, I've got a negative there. So I need to take care of that with i's. So I'm going to have x equals plus or minus I, and then I'm going to have the square root of 1 over the square root of 4, which nicely reduces down to 1/2. So for my answers, I have plus or minus I over 2, I have a positive 1/2, I have a negative 1/2, and I have 0. First thing I have to do is get it set equal to 0. So I'm going to subtract 27 from both sides so I get it set equal to 0. And I'm going to have x cubed plus 3x squared minus 9x minus 27 equals 0. As I'm looking at this, I'm going to see if I can pull anything out. And it doesn't appear that I can. Now I've got 4 terms, so that tells me I'm going to be using grouping. I am going to group the first 2 together and the last 2 together. So my first 2, I can pull out an x squared. When I do that, I'm left with x plus 3. Out of the last 2, I'm going to pull out a negative 9. So I'm going to pull out a negative 9, and then I'll be left with x plus 3. Now remember, this is that tiger problem that we did in a few videos ago. I bring my x squared minus 9 down together, and then I put my x plus 3 here. Now this x squared minus 9, hopefully you notice, is a difference of 2 squares. So I'm going to have x plus 3, x minus 3, and then bring down my x plus 3 again. Now that I've got it factored as far as I can, because all my x's only have an exponent of 1, I set each quantity equal to 0. And I end up getting x is equal to negative 3, or it's equal to positive 3, or it's equal to negative 3. Now notice how negative 3 happened twice. I don't need to write it twice. I would just put my answers down as x equals positive 3 or negative 3. So those are my zeros. Here's two more. First one is already set equal to 0. Then I have to try to factor it. It's two terms, it's a plus sign, and it's a cube. That tells me I'm going to be using the a cubed plus b cubed shortcut. So when I rewrite it, I'm going to have x cubed plus 3 cubed, and then I'm going to go ahead and fill in my pattern. So I would have x plus 3 times x squared minus 3x plus 9 is all equal to 0. And now I'm going to get x plus 3 equals to 0, or x squared minus 3x plus 9 is equal to 0. This first quantity, pretty easy to solve. Subtract 3 from both sides and you're going to get x is equal to negative 3. Now this next one, I can't just do algebra like I normally do because I have an x squared and an x. I can't factor it any farther, so my only option for finding the zeros that go along with this second part is using the quadratic formula. So I'm going to do the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Then I'm going to go ahead and start to solve that out. So I would have 3 plus or minus the square root of 9 minus 36, all divided by 2. And then I would have 3 plus or minus the square root. Notice I'm getting a negative here again. So we're going to have an I in our answer. I want to check, can I break down the square root of 27? And there's nothing on my list of perfect squares that'll go into it, so I end up with 3 plus or minus I square roots of 27 over 2. So I could have x be negative 3, or it could be this imaginary answer. And remember, there's two of them because there's a plus and there's a minus. Okay, on the second one, I'm going to subtract the 250p squared over. That way I get it set equal to 0. And then I'm going to look at what I can pull out. Well, 16 and 250, I can divide both of those by 2, so I'm going to pull a 2 out. And then p to the 5th and p squared, I can pull out a p squared there. So when I pull out 2p squared from both of these, I'm going to be left with 8p to the 3rd minus 125. And that's still set equal to 0. Now I can factor this 8p cubed minus 125 using the difference of two cubes. That 2p squared in front just comes on down. And then I'm going to have 2p minus 5 times 2p squared, which is going to be a 4p squared, plus 2p times 5, which is going to be 10p, plus my b squared, which is going to be 25. That's still all set equal to 0. It's as far as I'm going to be able to factor it, so now I set each quantity equal to 0. 2p squared equals 0, 2p minus 5 equals 0, and the 4p squared plus 10p plus 25 equals 0. First two are going to be pretty easy to solve again. When I solve the 2p squared equals 0, I'm going to end up getting p equals 0. When I solve the 2p minus 5 equals 0, I'm going to end up getting p equals 5 over 2. And the last one I'm going to have to use the quadratic formula on because I have p in two different spots. So go ahead and use the quadratic formula and see what you come up with for this one. So with our quadratic formula, we got negative 5/4 plus or minus 5i squared to 3 over 4. And now don't forget about our two other answers that we found earlier. Okay, here is your turn. Go ahead and find the zeros of this problem and bring them with you to class.